Okay, now for the next one, we are going to talk about the round robin. Okay, round robin is also another preemptive. Let me check on my recording. Yeah, should be fine. Okay, so for the round robin here, okay, now round robin is a very fair algorithm. Where's my pen? Aduh. Now, for round robin, it is a fair algorithm. Okay, why is it fair? Because you realize that there will be a time quantum. Okay, to practice this exercise, I assign a time quantum of 3 milliseconds over here. Okay, now it is fair because there is a time quantum, and how time quantum works so I don't care how many process there is, and I don't care how long your CPU cycle is for the process, but if you want the CPU to execute you, I only give you a period of 3 milliseconds. Imagine you have a process A of 6 milliseconds, right? If you follow the time quantum, right, this algorithm will fairly give this process to process 3 milliseconds based on the time quantum, and then up until 3 milliseconds, the CPU will be fair in a way that say, okay, even though you got 6 milliseconds, but you did use up 3 milliseconds, right? So we let the other process to process first, okay? Later only we come back to you. Okay, it's just that there is a time quantum to follow. Okay, if until here you cannot understand round robin, never mind. You draw this gun chart with me first, okay? So no matter what, you're going to start with 0, right? 我不要看到有人 start with 1, okay? Start with 0 and you gotta process A. So A come in first, A gonna be processed. So time quantum of 3, even though there's 6 milliseconds, right? You are going to run 1 millisecond, 2 millisecond, 3 millisecond. Okay, even though 6, you're going to say, okay, A. Wait, okay, here. Now we cut here. Okay, time quantum of 3 milliseconds, process for 3 milliseconds. Now at third milliseconds of arrival time, you got your B here, right? Okay, so B is another 2 milliseconds, right? So the A will later queue after the B lah, because there's no other process Okay, so there's only B here. So we say, okay, A, you go and queue up first here. Okay, let us progress with the B first, then we only come back to you because we want to ensure fairness. So over here you got your B. All right, B is just 2 milliseconds, so 4 milliseconds, 5th millisecond, done. Okay, 5th millisecond, there's no new incoming process, right? So B is done. You left A over here. So A continue to execute. Now don't forget you already execute for 3 milliseconds. So you left 3 only. You better not go and execute 9 milliseconds. Okay. So now A come back already. So A process for 1 millisecond. Okay. At this 6 millisecond. Okay. The C is here. Ta-da. And CPU cycle of C is 4 milliseconds. Now, can I stop here and then let the C go up? Can I stop the process A and let the CPU and do process C? Cannot. Because the time quantum is 3 milliseconds. So you're going to continue to execute for 3 milliseconds. 6, 7, 8. Okay, 3 milliseconds already. Cut off. A is now done. So in your queue, you have only C, right? And 8 milliseconds, there's no new process coming in. So your CPU at this moment will continue with process C. Okay, if you cannot understand, go and text me. Let me show you another example for this one. Okay, now C is already, A is already done. So over here, A is done, B is done. Now go with C. C is 4 milliseconds. So I execute for 1 millisecond, 9. Okay, at 9, you got something coming again, which is process D and having a CPU cycle of 2. Okay, now I cannot say, hey, C, you hold on, let the CPU process D because time quantum is 3 milliseconds. Unless the time quantum is 1 millisecond, okay, now you let go the CPU. You let the CPU for D. The C go and wait for a while. Okay, but now time quantum is 3 milliseconds. So we're going to execute for 10 milliseconds and until 12. 3 milliseconds already, right? 9, 10, 12. So at this moment 12, we're going to stop it. Okay, at this millisecond 12, we're going to stop it and the C is going to queue at the back, right? Okay, because you see, Over here, C is 4 milliseconds. So you are going to deduct with 3 and then you left 1 more millisecond. Is this one done? No, right? It's going to queue behind. And bear in mind that you see at 12 milliseconds, you have a new incoming drop as well. So your E is going to queue here, okay, with a CPU cycle of 4. All right. Now, where does C goes? Look at here. Because your C end here. So some of you may confuse that you are going to queue your C in between D and E drop. I mean these two process, okay? Or is it going to put the C at the end of here? Okay, the answer for this now you see D coming already, so definitely the next one is going to process D. But at this timing, the E come as well. So C is just done, right? So C have 1 more millisecond. We are going to queue the C over here, C with a 1 millisecond. Okay, so then we process with the next one, which is D of 2 millisecond. Okay, so 13, 14, 14. Okay, E is here. Okay, E is here. Now you do E, but E is 4 milliseconds. So 15, 16, 17. Go time quantum of 3 milliseconds. Cut. Okay, cut already. We put it back for this C, which have 1 millisecond. Okay, then followed by E, another 1 millisecond. Okay, so this is for the round robin. Okay, now let me pause for a while as well.